We are given the function f of x equals x cubed minus 5, x squared plus 3, x plus 2. We want to find values of k between 0 and 3 such that the slope of the tangent line at x equals k is equal to the average rate of change of f on the interval from 0 to 3. Then we want to compute the product of these k values. Let's begin by finding the average rate of change on the interval from 0 to 3. First, calculate f of 3. That is 3 cubed minus 5 times 3 squared plus 3 times 3 plus 2, which equals 27 minus 45 plus 9 plus 2. That simplifies to negative 7. Next, calculate f of 0. That is 0 cubed minus 5 times 0 squared plus 3 times 0 plus 2, which equals 2. Now the average rate of change is f of 3 minus f of 0 divided by 3 minus 0. That it is negative 7 minus 2 all over 3, which equals negative 9 divided by 3, or negative 3. So the average rate of change on the interval is negative 3. Here, let me point out something important. Whenever we compute the average rate of change over an interval, there is guaranteed to be at least one tangent line inside that interval, whose slope is exactly the same as this average rate of change. Later, we will study this formally as the mean value theorem, but it is helpful to start understanding the idea now. Now let's find the derivative of f of x. The derivative of x cubed is 3x squared. The derivative of negative 5x squared is negative 10x. The derivative of 3x is 3, and the derivative of 2 is 0. So the derivative is 3x squared minus 10x plus 3. We want the slope of the tangent line at x equals k to be equal to negative 3. So we set f prime of k equal to negative 3. That gives the equation 3k squared minus 10k plus 3 equals negative 3. Or equivalently, 3k squared minus 10, k plus 6 equals 0. By the relationship between the roots and coefficients of a quadratic equation, the product of the two roots is equal to c divided by a. Here, c is 6 and a is 3. So the product of the two k values that satisfy this equation is 6 divided by 3, which is 2. Therefore, the final answer is that the product of the ka values is 2.